Started with floatation, you know, upthrust. Did we start with upthrust? Where did we stop? Did we cover the reason for upthrust, Archimedes' principle? What? Archimedes' principle. Yes. Archimedes' principle, not cancer. Show me the notes. Okay, so we started upthrust with notes. And we had discussed the conditions for floating bodies. Okay, fine. I'll just keep my book. Okay. So upthrust. So I think in the last class we discussed that any body, when we try to submerge in liquid, it experiences upthrust. Okay. And how much is that upthrust? How much is that upthrust? Any idea?
No.
You're right. Right. So
The
okay.
weight placed by the submerged body.
Weight of what?
The weight of the body is put into the container.
The weight of the liquid placed by the
Replaced by
Weight of the liquid. Right? So suppose you have a, let's say you have a body whose weight is W. Weight is W in air. Now when it is put inside liquid, will its weight be same? Will its weight be same? No. It will be more or less?
Less.
Less. It will be less by how much? Upthrust. Okay. So the apparent weight of the body is W minus FE. This is what it is. So its weight reduces by upthrust. So I was asking, how much is upthrust? This upthrust is equal to weight of liquid replaced by body. By the body. Okay. So this is the weight of liquid replaced by the body. So how much it will be? So how much is weight given in terms of volume and density? The volume of liquid will be same as this body's volume. Correct? So let us say this body's volume is V. So weight is given as mass of the liquid replaced, right, into gravity. Correct? Mass of the liquid which is replaced by this body. And what is mass and density relation? It is volume of the body times density of the liquid. This is V. V is volume. Volume of body, which is also equal to volume of liquid replaced. Replaced by. Understood? So both the volumes will be same, isn't it? Whatever is the volume of this body, it will replace same volume of liquid, and that is why what is rho? Density of liquid. Okay. So my question was, how much upthrust is exerted by liquid on this body? It is this much. Okay. And if you talk about the weight of the body, what is the weight of the body? W is equal to mg. And m will be mass into density of the body, and v. So weight is always written as V rho. Is this clear? So here W is weight of body in air. So if you understand these two things, this chapter, there's nothing else to be understood in this. You have to only understand these two things. How the weight is expressed in terms of volume and density of the body. And this is density of liquid in which it is submerged. And this V is the same volume of liquid which is replaced by body. Both the volumes will be same. Okay, so this is what we did in the last. Okay. So today now, and we also discussed the reason for upthrust. Okay, so we discussed about upthrust, and then we also discussed, if I remember correctly, what is the cause of upthrust. Can anybody tell me what is the cause of upthrust? Why upthrust is caused?
For the density of the liquid is more than the
Density of the liquid is more. Why? If the density is less, it will not cause upthrust. The density of the liquid, if it is more or less, will affect whether the body will float or sink. But upthrust is caused more upthrust or less upthrust. That is the only thing. So whenever you try to submerge your body in liquid, it will cause upthrust. My question is, what is the reason for upthrust? Hmm? The reason for upthrust is the difference in the pressure at different layer. Here the pressure is P1. Here the pressure is P2. Yes, pressure acts in all the directions. So here the pressure is P2 and here the pressure is P1. Is P1 and P2 same? Which pressure? P2 is greater. Why?
because the depth is better.
Yes, it is at the greater depth. So it is due to the difference in the pressure. Okay. The body experiences more pressure at its bottom than at its top. And wherever there is pressure, right? Pressure into upthrust. So pressure into area of cross section, right? That will be the upthrust due to the water. Okay, that's how it is. So this P2A minus P1A. Right? Because what is pressure? Pressure is upthrust upon thrust upon area. So here the thrust is downward, but here the thrust is upward by the bottom layer. So if P2A is greater than P1A, obviously P2 minus P1A. Okay, so this is the reason for upthrust. And then we said, what is P2? P2 was H rho G, right? This is H2, and this will be H1 rho G. So all these things we did in the last class, but I am just doing it again so that you are with me. So how much is this? H2 minus H1 rho G, right? And what is H2 minus H1? If this is the height of the box, let's say this is the height. This was the height, right? This will be H2 minus H1, it will be H rho G. But base into height, what is it? And this density is density of the liquid because we are considering liquid, right? This is density of liquid. What it is. Okay. So we just discussed what is the cause of upthrust. It is the difference in pressure at top layer and bottom layer of the body. That is the cause of upthrust. Is this funda clear? And it is because of this upthrust, this weight of the body when it is submerged in water, it is now this is the actual weight inside the body. I mean the apparent weight. Weight in liquid is actual weight in air minus upthrust. That's why the body becomes lighter. Okay, anybody has any questions till here? Huh?
I didn't understand this.
You were the one who helped me in the last class to get this part. Okay, so what is it is, what is FB is, so I was trying to explain the reason for upthrust. Reason for upthrust. First we said we have a body whose weight is W in air. When we put it in water or liquid, it experiences upthrust. So it has a less weight, which is weight in air minus upthrust. Then we discuss what is the reason for upthrust. It is the difference in the pressure at the top layer and the bottom layer of the body when it is submerged. So at the bottom layer, pressure is more due to greater depth. Okay. So, but pressure is force upon area. I mean thrust upon area. So if we multiply pressure with the area of this body, so with where the pressure is exerted, P2. So that is the force at the bottom. So that force at the bottom, let's say we call F2, right? So that F2 should be equal to P2 into A. And F1 should be equal to P1 into this area. Okay. So obviously F2 is greater than F1. So the difference must be upthrust. The net upward force is upthrust. Okay. So then we just did this. So this calculation we have done in the last class also, right? Now we will proceed with understanding what is Archimedes' principle. So Archimedes' principle is nothing but we will write all this in English. Okay, that whenever a body is submerged in liquid, it experiences upthrust on it, which is equal to the weight of liquid replaced by it. That's it. That is Archimedes' principle. This whole thing we are writing in English statement. Okay. Shall I erase it? So whatever we discussed mathematically, what is Archimedes? Archimedes, is it spelling mistake? Is spelling?
Archimede'sPrinciple.
Archimedes. Okay. It states that whenever body is submerged in liquid, right, it experiences upthrust on it. Right? Which is equal to the weight of liquid replaced by it. So I can write upthrust as P What is the weight of liquid? Remember it is. So this is just for your memory. What is upthrust and what is the weight of liquid with this weight? So there. So this is the full statement. There. V is it's all. So that's what it is. So yes. Okay, so we will only urban body of liquid replaced by OL is density of liquid. So that is my so replaced or displaced. You can write displaced. When replaced has a meaning like you replace it with some other liquid, but actually it is getting replaced by the body itself, but then displaced. Okay.
So if I use the word replaced, that means
That liquid is when it's gone, but it is there around.
it is there, it's still there, so
Yes.
that's why we
That's why displaced.
so that's why we need to water the volume.
The level rises
The
up,
level
right?
rises.
So liquid is really not replaced, it is displaced. That's the time. Now, experimental verification of Archimedes' principle. So is everybody's concept clear till now? So we now go further. Experimental verification. Let's see. In the first case, we'll verify on a beam balance. Right. Experimental verification of Archimedes' principle on a beam balance. So what we are doing is on the left side, we are hanging two cylindrical containers, right? This one is hollow, and there is identical cylindrical container. This one is solid. Two identical cylindrical containers. This one is filled, okay, and this is hollow, right? And that time we are keeping some slotted weights to balance it. Okay, so this is an equilibrium. Left side is equal to right side weight wise. Okay, the masses are equal. Now what we are doing is we are introducing beaker filled with liquid. Right? What did we do? We, through some arrangement, brought a beaker filled with liquid and submerged the lower cylinder into it. What should happen on the lower cylinder? Upthrust. So if upthrust acts on it, will the equilibrium disturb? Yes. So what should happen? This should tilt. Okay, toward that. Yeah. So you will see that this has come down and this has gone up. When we keep a liquid filled beaker below it. Okay. Then what are we doing? So what is Archimedes' principle? It experiences upthrust on it, which is equal to the weight of liquid replaced by it. Right? So it experienced upthrust and therefore it got disbalanced. So to balance it again, what did we do? We will now fill liquid over here. We'll put, this was hollow, right? Okay, so now we'll completely fill this with liquid. We see that it balances again. Okay, so if it balances again, that means this much weight of liquid must have countered or neutralized the upthrust, isn't it? So does it not verify Archimedes' principle? Huh? Has it verified Archimedes' principle? Yes. Because in this hollow cylinder, when we fill it up, and we said the volume of this and this is same. So this volume of liquid's weight is same as the liquid replaced by this. Okay. So therefore, it proves the Archimedes' principle. Understood? Read the description given in the book. Let's see if it is clear to you. There are 3 steps. The first step here is balanced. On single cylinder. Filled cylinder. The second case, cylinder. Is submerged. So solid cylinder at the bottom. The submerged in liquid filled container as shown. This one is tilted on the right side. Okay, which means it has suffered weight loss. Right. And in the third case, what happens? The first cylinder and liquid is filled. So which liquid? Same liquid, huh? Liquid is filled. Is balancing. This verifies do we all agree? This where what the liquid is. This upthrust, which is making the being filtered, gets balanced again when we fill this liquid by this much weight. So whatever is this volume, same as this. Is it clear? Look at the second experiment.
Questions. So first cylinder and the second cylinder weigh the same.
Identical.
They are identical.
Yes.
So the water weight displaced by the water would be twice that of one cylinder, right?
Why twice? Only one is submerged. Huh?
Only one is submerged, but then that also has the weight of the second one on top.
No, but what is experiencing upthrust? Only the second one.
So
Not the
only
first.
one. The
Yeah, this is in air only, no? This one.
yes.
Only second one. The lower one is submerged in water. It's like two of you are hanging, right? One is holding the leg of the upper boy or girl. So, so the upper boy will feel weight because the lower boy is hanging, right? But if somebody holds the lower boy or girl, then will he experience the weight? No, because now there is no gravity or there is no same gravity, right? Something like that. Is it making sense to all of you?
Which my question was, the weight is getting added into the tank on top of CD. In the liquid, we have
Upper or lower?
upper.
Ah,
We are filling the can, right?
yes.
So it's making a difference on the lower can because of gravity.
So it is, so when we fill it, right? So how much weight it is increasing? It is the weight of the liquid which is filled in this can. Now we are seeing it is balanced, which means it has negated the effect of, neutralized the effect of upthrust.
Okay, okay.
So it was exerting upthrust, right? Because of which the beam balance got tilted like this. Earlier both were equal when they were hanging in air. But now when the liquid was introduced due to upthrust, this got tilted like this. Now when we filled it again it got balanced. That means this liquid's weight must be equal to this force, which is what is Archimede's principle. And why we are saying it is equal to the weight of liquid replaced, because this volume is set. Okay. Now look at the second experiment.
It's the mistake and what the pronunciation.
Eureka. It's a Latin word. Eureka means I found it. It's like I discovered. Okay, that's what Archimedes, after discovering this principle, the legend says he started running on the street, okay, shouting Eureka, Eureka. I found it out.
So what the
So,
mistake and
so
was?
for his honor, the can is named as Eureka can. Okay, it's the name of this can. What is that Eureka can? This type of code, this type of code, which has one pipe. The name of this vessel is Eureka. Okay, that is part of the second experiment. Yes, you were saying something?
Yes, so I was saying the mistake I made was that I thought that adding the volume of the can
I think the volume.
like adding a cylindrical,
No.
adding.
So this both arrangement were already balanced initially. Then when we introduced this water or liquid, that time it got disturbed.
So I thought when we introduced the liquid, the upthrust got increased.
Yes, upthrust got increased. That is why it went up. No? Upthrust increase means the force was applied from bottom up.
Right.
Yeah.
But that is the truth. Like that is.
That is what is that is Hindi.
मतलब मैंने assume करा था that upthrust decreased. When I assumed that the upthrust increased, that's why मेरा question को मैं समझ.
You're mixing two. I will forget upthrust now. Upthrust. See, gravity. See, listen. Weight is always downwards. Weight is always downward. And therefore, we kept slotted weights here to balance it because both are downward. So, both sides, when they are equal, this beam will be balanced. Okay? Weight is always on. Up thrust is the thrust which is in the upward direction, opposite to the direction of weight. तो इसमें upthrust लगा liquid की वजह से, इसलिए तो ये ऊपर गया. So that's it. Okay. ठीक है. So ये ऊपर चला गया तो we balance it again. फिर से liquid डाल दें. That means the weight of this liquid, which is equal to the volume of weight of liquid replaced by this can. Must be same. Isn't it? Because it got rebalanced again. Okay. Now second experiment is, you can verify it like this. So you have a spring balance. Okay. And you have a weight here. So it is showing how much? 300 kilogram force. What is the weight? 300 kg here. Okay. Now, when you do the same thing, there is a Eureka can, right? Filled till this. So there is a water filled till this pipe. So when this is now submerged in the Eureka can, so some liquid will now flow out, displaced. Okay. So whatever is the displaced liquid is measured. So that displaced liquid is about 100 ml. Okay. So 100 ml. So that is the volume, and density of water is 1 gram per centimeter cube. So 100 into 1 gram per meter cube per centimeter cube, that will give you how much? 100 gram force. What is the weight? Right? How much is this? V is
Volume.
100. Density is 1. And this is gram force. That's the force, isn't it? So you're not multiplying G, you're saying gram force. And here the force, here earlier force was 300 gram force. Right? Okay. So then, so from 300, now it is showing 200. Right? So what does it tell you?
100 gram liquid is displaced.
So weight of 100 gram, what is the weight of this? 100 gram force. So that is the weight of the liquid now. So it is not directly proved. When the difference is only 100 gram force, and you see that 100 gram force of liquid was displaced. That is Archimedes' principle. Got it? Got it or no? Because here we have used density rho L is equal to, for water, let us say, is 1 gram per centimeter cube. This is the volume. What is density of water in SI unit? 1000 kg per meter cube. You know this, right? So since this is in gram force, we are using CGS unit. Don't get confused. Learn. ठीक है, हंसो मत अभी, बाद में रोना पड़ सकता है. This is 1 and also 1000, depending upon what system you. So this is calling 100 gram force. Okay, where is it written gram force? Read written gram force in here in the question, in the description. Okay, so read it quickly. It will take 5 minutes, but then your concept will be clear. Yeah, experiment 1, throw out, I suppose. Read 2 completely.
Experiment for my exam.
This one, very good. But is the concept clear now? Anybody has any doubt, please get it cleared up, because if this does not get cleared, then this confusion will continue. And in this chapter only this is to be understood. Upthrust, weight of the liquid replaced, that's it. If you understand these two, then this chapter is done. So if anybody is not understanding anything, just let me know. All of you are following Selena, right? Is there anybody following any other publication? So everybody is following that. So we are good. Selena is a better book. That's what I also follow. So if you don't have any doubts, I'll proceed. Shall I proceed? So what is next? Conditions for flotation, right? What's the next topic? So this basically means conditions for Floatation. Now, hear me out. Hear me out, everyone. So you have a body which weighs W. Okay. Now I submerge it in a liquid, which causes upthrust on it, FB. Okay. Now, when should the body float? When FB is greater than or equal to the weight of body. Okay. So what should happen? Let's say this is the situation, right? So I am giving you three situations. This, this, and this. Right. So what is this situation? Greater than W, then it will hold it. Right? So the upthrust caused by only this much portion of the liquid itself is sufficient to hold it up. Okay? So how the Archimedes principle will be modified in this case when a body is only partly submerged? So in this case, the weight of the full body is balanced by the upthrust caused by the liquid replaced by the submerged portion of the body. Okay? Is the body floating here? Yes, it is. Has it sunk? It is not. It is floating but fully submerged. So both are cases of floating. But what is the difference? Here FB is greater than W. Here FB is equal to W. Okay, so you are swimming with your nose and mouth up on the surface. Right? Have you seen people swimming with only nose and mouth up? Sleeping on their back and floating. That's what it is. This is the case when W is greater than upthrust. So all three things are explained to you. Right? So body will float. Will float. If FB is greater than this. So this condition taking further, right? What was FB? Mass of liquid into gravity greater than or equal to mass of body into gravity. What was this? Volume of liquid replaced greater than or equal to volume of body, same body, right? Density of body, mg. So you can cut this. This gives us that density of liquid is greater than or equal to density of the body will flow. So both mean one and the same thing. You don't agree? Do you agree or no? What do you agree?
That volume of liquid is
Yeah, others say no. Try. Even if it is wrong, it's okay with you. You should try. But you should try with understanding. Force is, what is this force? Why did I write MLG? Because it is the weight of the liquid replaced. Okay, na? So weight of liquid replaced will be the volume of liquid replaced into density of it. That's it. We discussed ना पिछले slide में, पिछले note में. Okay. ठीक है? Next. So this was case one. Body will sink when Same. If density of the liquid is less than density of the water. Okay? Then it will not be able to hold it. By the same logic, just reverse the relation. So if anybody has any question, please feel free to ask question. You ask me question in the language you are comfortable. And the language which I understand. Speaking English, Marathi is fine. Yes. Speak in Malayalam, then I'll use Google Translate. Any other language? Then I'll use Google Translate. Do not go back unsatisfied. Okay, feel free to ask questions. Open up. I think only she and one or two, very few are asking questions. I mean, boys. Yes. Really, that makes me so happy.
No, but when I read it by myself, I get lots of doubts. For the time I don't have.
See, not having doubt is a good thing, but is that illusion? In reality, if you don't have doubt, that is good. Like when I'm teaching, it should be like a story, okay? Listening to a story. But retention also should happen. That retention will happen when you understand. So when I'm teaching, okay, so when you understand, you try to start correlating with situations. Then that thing will happen. And you will be able to test yourself when you start solving numericals. Okay? Oh, yeah, exactly. So why am I stressing so much? Because physics is totally concept. It's not mathematics. It is next level. Mathematics is the tool needed to do physics. Physics is the application of mathematics. You understand? Base of engineering. So maths is the tool. But then to make building, you need tool. But you should have the design. That is physics. How the building will look like when it is finished, that is physics. How you will lay bricks, okay, that is mathematics. No, both are complete in their own respect. It's like there is an artisan and he uses tools, right? Using tool, he brings the sculptures to life. You understand? So the finished part is physics, but you need tools to manifest it. So end result is physics, but you need mathematics to achieve that result. So you need both. So that's why. So it is conceptual. So first you have to understand, then you have to quantize it. Then only you will be able to apply it. So it calls for beyond logic. It calls for some imagination also. That is where a lot of you initially are uncomfortable, but you get habituated. So it's a different approach needed, that's all. Like in mathematics, you understand the formula, then you just go on building over. It's not like that. Here the relation has a meaning and you have to understand that meaning also. It's not just greater than equal to what does it mean? It is about floating or sinking. Okay? So when you relate it with yourself, then you will start appreciating. All right. So with this, I think are we done with this part of the chapter? Do you have anything else left? So bodies of density is greater than that of the liquid sink in, while bodies of average density equal to or smaller than that of the liquid float on. Okay. Shall we start with the relative density? How much time we have? We'll do the numericals in the end. Okay. 761. So let me start with the relative density, the next topic. But before I start relative density, are you okay till here? All of you? All of you say, give me a confident yes, not like,
Yes.
yes, बोल रहे फिर मैं भी बोल रहा हूँ, not like that. ठीक है? All okay?
Yes.
Sure. Again, she is looking somewhere. Okay? Sure. Give me the confidence. Okay. Now relative density.
Body in air, weight of the body in air.
You will do it. All in red. No, because not enough time. The virtual will take at least a lot of time. I'll start and then time will. We will do the virtual, don't worry. I will not let you go without it.
I have 7 minutes.
This is what I want to break.
No, I don't have very fast.
I'm there to make you do that. There is only one formula in this. What is that? E is equal to H rho G. That's
That
it.
is fresh.
And the second formula is only the application of your past knowledge. What is it? Density is mass upon volume. That's it. In this chapter, you only learn one formula, pressure, thrust upon area, and then that becomes H rho G. That's it. एक ही formula. Okay. I'll make it easy for you, don't worry. But right now, help me. You help me help you. You understand? I always use this. You help me help yourself. Help you. Okay. What is relative density? It is nothing but relative density of relative density of a substance. Say kerosene. Okay, relative density of the substance is equal to density of the substance divided by density of water. At 4 degrees Celsius. So relative density of a substance, that is relative density of a substance is equal to density of a substance divided by density of water. That's why we say relative, it is comparison. Comparison of density of any substance with density of water is its relative density. Got it? And density of water we know since we took birth. We know it because we took order. What is that? 1000 kg per meter cube, right? So density of water सबको पता होना चाहिए. और किसका density पता होना चाहिए? Density of mercury. How much is that? 13.6 times the density of water in any unit. Density of mercury is 13.6 times density of water. So it will be 13.6 into 10 raised to 3 in SI unit, or just 13.6 grams per centimeter cube in CGS. Okay. So this is what it is. Why are we taking density of water at 4 degrees Celsius only? Huh? It has?
a maximum density.
Yes.
So what is written there? S.
S is the substance. Yeah. It has the maximum density at 4 degrees. You know that property of water? What is it
Yes,
called?
anomalous behavior of lines.
Anomalous behavior of water.
After 4 degrees session, start.
Expanding.
Expanding.
If it
4
con-
degrees contract.
So it's like this. So volume, let's say if you draw a graph of volume versus temperature.
Because at
Right.
bounded.
So volume of water is minimum at 4 degrees. and beyond that it increases. Okay, you must have studied it in chemistry and all. We will study it again in heat chapter, anomalous. So don't be lost. Okay, there is a different way in which you have to start learning physics. So then it becomes easy. Once you decode that logic, it becomes very simple. A lot of you just get psyched. There's nothing to be psyched. Just follow the rules. Okay. So what did we learn today? We learned that when are we going to float and when are we going to sink,
Basically, Archimede's
which is Archimede's principle.
and
So
we
we'll-
learned about
Relative density. So what is the significance of relative density? Now that you know this, what substances will float?
substances on which the substances which are lower density.
Which
that
Lower
will be equal to
Just
No,
lower
in terms of relative density, which substances will float in water?
substances that are less density than water.
So the substances which has less density than water will have density, relative density less than 1. Okay, so all the substances whose relative density is less than 1 will
Lower, because it has more than.
will float. I just to confuse you.
more than 1.
तो ये समझ आया? So what is the significance of relative density? वो बताता है कौन सा substance water की density से उसकी density ज्यादा है. So it will not have any unit because it is a pure number. If the relative density is greater than 1, sink होगा. If the relative density is less than 1, that means वो float. क्यों? Less than 1 कब आएगा? When the density of the substance is less than density of the. अभी तो less than 1 आएगा. Got it? So there are various ways of representing the same thing. अभी एक relative density इसलिए है क्योंकि water एक standard चीज है which is available everywhere and we know its density. So that's a reference density. तो बाकी substances या तो water से ज्यादा होंगे या तो water से कम होंगे. और आदमी डूबता या तैरता है कहाँ? नदी, तालाब, समुद्र सब जगह water है. ठीक है ना? That's why water has been taken as standard. बोलो water क्यों standard है? Because it is available in abundance. ठीक है, एटमॉस्फेयर वाटर जो अबेंडेंट है उसी को रेफरेंस बनाते हैं बिकॉज वी कैन रिलेट टू इट बेटर. ठीक है, सो अगर अपने को रिलेटिव डेंसिटी पता है कैन वी फाइंड द डेंसिटी ऑफ द सब्सटेंस?
Yes, because if you know the relative density or what is the density of the water, then we can find the density
वेरी गुड,
by substitute.
एग्जैक्टली. ठीक है, ऐसा है. So these are the types of questions which comes. Relative density दिया रहेगा, they will ask you find the density of substance. So they expect you to know the density of water. This standard. Are you with me? So trust me, Americans में यही सब पूछता है, तो मैं भी बता रहा हूँ. Why is not pressing the buzzer? It's already time, right?
Yes.
1 minute past. Chalo, so I'll see you in the next class then.
What happened?